Hey guys, welcome back to the channel, and today we are going to design this Allen bolt. Now in case if you have been watching my videos, I have already done this, but the audio was not included as well as the explanation was not to the point. So I decided to redo this again, and we are going to model this Allen bolt very quickly. So let's start with from here. Let's create a new document, go to part, press OK, and then you can enter the part name if you want to and press OK to confirm. We are in the new part design environment, so let's sketch on the YZ plane. We are going to take profile, and from the origin I can pretty much draw a profile like this, simple profile. Alright, and then we'll go for constraint and quickly give constraints to my sketch so that it's fully defined. Now I'll select this, right click and go for horizontal measure. Same one to this, right click, horizontal measure. I want to give a angle constraint between these two and angle constraint between these two as well. Alright, I can define this one, and what else? Okay, so a distance from here to here. Now since my sketch turned green, I can get out of my constraint, and to enter the exact value I will utilize here edit multi-constraint. So what it does is you can change the values of your constraints. So I will start from here. So highlighted values will be shown in red, and you can enter your desired value. Let's say 8, and this one could be 6.5. This is 30. This is 30, and this one is 0.5. This one is also 0.5. This one is 30, and this is 4. Once you have entered all your desired values, you can press OK, and one more time OK, and your sketch will be changed to your new values. Alright, from here you can exit the sketch and go for a shaft definition, and for the shaft we will select this as the axis. We'll keep the angle as 360 because we want it to be fully. Now if you see this kind of view, you can always come here and change it to shading with edges. So here is my Allen bolt basic part. Now I need to do some modification, maybe some hole on this face and then some grooves, or you can say the screw part on this face. Alright, so for that I'll select this one face and go to sketch, and we'll select hexagon over here. Draw a hexagon like that. Select the constraint. Select any two opposite faces and give it a dimension of 6.5, and you can exit from the sketch. Now I will go for a pocket, and in the depth let's take for 7 mm depth. That's fine. Yeah, now we need to do some modification for this face. So I'll go for YZ plane, go to sketch, and this time I will select profile. From the origin I can draw a rectangle like this. Alright, and go for a constraint, give it a dimension of 4. Also we can define angle between these two. So let's say angle between these two is 30°. Now I will switch my view to wireframe, and we'll draw another triangle. So I'll draw a triangle like this, basically a right angle triangle. And why I switched my view to wireframe is because I have to make this edge and this edge coincident, and if we have not switched it to wireframe it was impossible. So this one is again same 4 mm, and the angle between these two is obviously 30 mm. From here you can exit the sketcher and you can change it back to your shading with edges and go for a groove. You can select the axis as this one. You can preview it if you want to and press OK. That's what I wanted to do with my sketch, and that's perfect for now. Furthermore, let's focus on the screw thread over here. So for that I will select YZ plane again and go for sketching, and this time I will define a point over here and we can give it a dimension from here for about 4 mm and select this point and this one and go for coincidence. You can exit the sketch from there and you can apply a chamfer before that. So this face 0.5. Okay. Alright. After that we will invoke the helix command. So I'll type in C hash helix, press enter, and your helix curve definition will be activated. Now we need the starting point, so I'll create this point which we just created. For the axis I will select this one, and obviously it should be on the opposite direction, so I will reverse the direction. I can pretty much change the height. So for the height what we can do is we can go for, let's say, of about 28 mm. Can preview it. I think that's fine. Can go for clockwise. You can keep the pitch 1 mm or you can change it. So let's say let's make it to 1.25. Preview it, press OK to confirm. Now once I have my helix, I will select YZ plane again and go for sketching, and this time I will zoom into this area, and with the profile I'll draw a triangle over here and we'll give it a dimension. So this edge, and an angle between these two. So this could be 60. This is 0.5. This is 0.5. Okay. Now what I will do is I will take this point and I will select this edge. Go for constraint, right click, go for midpoint, and this point will be on the midpoint of that edge of the triangle. That's what we wanted. From here we can exit the sketcher workbench and we can go for a slot. Now since we have already selected the profile, all we have to do is select the curve. So I will select the helix as my curve, and profile control I will change it to reference surface, and we need to define surface, so I'll select this as the surface. From here you can preview it and then press OK to confirm. You will get a warning, but you can get rid of that, and here you have the Allen bolt. Quick and easy, nothing complicated, just have to use the correct helix definition, and that's it with this tutorial. I hope you guys like it, and if you have any doubts regarding this one, feel free to comment down below and subscribe to the channel if you are watching. See you in the next tutorial. Peace out.